Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because he's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone, which is really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother. I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary. That is, the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
Uh, so hello everyone. Welcome to this lecture. I hope I'm audible. Can you please, Amar, can you please give a thumbs up if you can hear me?
Yes, you're loud and clear.
Okay. So yeah, so welcome to today's class. Yesterday, what we were actually doing, I will just give you a brief about it, and then maybe we can start with today's class. So give me a moment. So yesterday, what we were doing was actually based on the ANSYS setup that was majorly important in order to analyze whatever model that you have got or created into uh, by studying the concepts of electric vehicle or autonomous vehicle. Thereafter, creating that model into ANSYS, and then thereafter doing the analysis of the same to evaluate the coefficients which are necessary to evaluate the performance of the vehicle. So that was mainly an important task. So yesterday, what we were doing was to get a grip or understanding about the software answers, majorly understanding the main primary, uh, 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 main primary this thing primary toolbox options that were present into the software, and thereafter taking it forward to the next step, uh, creating an enclosure of the same, and then doing a mesh convergence study, understanding what are the different terminologies of the mesh, not very much into detail, but yeah, on a surface level, getting to know what are the significant parameters that actually evolve the performance or quality of the mesh. And thereafter, once that is being understood, uh, we can actually we have taken that complete system uh, of mesh. So we took different qualities of mesh, coarse, medium, and fine. So three different qualities of mesh. We took those qualities of mesh into the solver that is Fluent, and then analyzed it. Then analyzed it using Fluent solver. Thereafter, we actually evaluated the performance by calculating the aerodynamic coefficients, and then thereafter deciding uh, a basic understanding that its variation with the amount of variation of the mesh parameters, the mesh uh, size, the inflation layer, and everything. So what we came to know was we were actually taking a understanding of a parameter called orthogonal quality or skewness. So once that is being understood, we came to an understanding that if the skewness would be around zero point 0.5 or less than zero point 0.5, then we are in a good condition where we could say that each system is well meshed. So just a minute. So that was our set of understanding, and keeping that into consideration, we took that model into Fluent, and we took that model into Fluent, and thereafter we analyzed the model with different two different mesh parameters, and came to consideration that force mesh is only force mesh is only sufficient enough in order to get a uh, proper quality of the system level modeling. So that is how we actually did it. So now let me show you my screen. Uh, so yeah, I hope my screen is visible, and I am audible. So Amar, could you please confirm it
Sorry,
once again?
you are audible, but screen is not visible as it's loading now. Yeah.
It's fine, right?
1 minute, sir, it's loading.
Okay. Okay.
Yes, now it's visible. We're able to see your Excel sheet.
Okay. Okay. So now this was the sheet that we prepared yesterday. So we took the number of iterations, one and two, wherein we changed the number of inflation layers and inflation boundary layer height, and varied the mesh size from 10 mm to 5 mm, varying the mesh elements and evaluating the quality and the skewness ratio. So with the coarser and the finer mesh, upon convergence of a different continuity and XYZ velocities, we came to an understanding that our CD and CL parameters are actually matching in both the cases. So that comes to an understanding that this complete set of modeling is actually under the accurate regime realm. So we'll continue it from in the same manner in today's class as well, wherein we'll actually evaluate two different geometries of electric vehicles. So yeah, based on I got a chance to evaluate whatever was taught in the previous previous theoretical lecture classes of electric vehicles. So based on that itself, I uh, will actually give you two geometries today for the electric vehicles. One will be a bluff body uh, electric vehicle, and the second one will be an aerodynamic uh, body electric vehicle. Okay, and both the cases will actually evaluate the performance that is very much important in the electric and autonomous vehicle. That what is the performance of the vehicle, and once that is evaluated, we will find out the performance in ANSYS by meshing, creating the domain, and then the geometrical understanding and convergence criteria. And once that is done, we'll come to an understanding of the performance parameters of the same. And once that complete system is built, we will evaluate the thing in ANSYS. So ANSYS fluent. So let us take one. Yeah, so let us take one by one. First, we will do a. So we have two geometries today for electric vehicles or autonomous vehicle, whatever you can say, ground autonomous vehicle, and we'll do the analysis of the same one by one in ANSYS and evaluate the performance and fill the sheet in the same manner. So yeah, let me share the screen. So let me create another wherein I'll write serial number and mm, then C D, then velocity, then mechanical power. And mechanical power is nothing but drag into velocity. So it is nothing but the multiplication of drag into velocity. So we'll be computing the drag here, PD. So let me write another way, mechanical power, CP we can write, mechanical power coefficient. Okay, so we'll be doing it for two cases, serial number one and serial number two. We'll be doing it again for 20 meter per second. Okay, both the cases. And here is the performance sheet, and below that will be the mesh sheet where we'll write the serial number, then serial number, then sorry, number of elements, uh, then element size, then inflation layer, then first layer. Okay, so let me wrap it. Okay, so this is also 1 and 2. So numbers, elements, and all that, we'll write it down. So first we'll take the geometry here. So let me take the geometry first. So first we'll take EV car first one. Okay. So yeah. So I'll make a very simpler model of the car setup. I'll take a 2D sketch. I'll plot it over the surface and then I'll show you how to do it. Just a minute. Let me take this thing. So this is one model, but I will take the second model first. Mm, yeah, so, yeah, so I hope I'm clear. People, can you please reply on the chat if it is fine? Amar, I'm audible, right?
Yes, sir, you're audible, and your screen is also clear.
Okay. So let me now take this complete section into picture, wherein I'll project this over a plane. I have projected it over the plane and I'll try to trace it, okay? To get a 2D plane first. And then after that, once that is done, we can create the 3D geometry out of it. So yeah, I'm trying to trace it completely over the 2D plane sketch. And once that is done, we can take this forward. So please follow with me. And in the meantime, if you have answers also in your place, you can also try to replicate the same, or else you will have the recorded sessions wherein you can get get these lectures and you can practice it at your own end. So this is an electric vehicle for which we are trying to evaluate the performance of the complete system. So performance is basically a very generic. So performance totally depends upon how you are trying to view that complete system. So I'm trying to view that complete system in the basis of fuel consumption and efficiency. So definition lies on. So performance is a very generic term. So it totally depends upon your way of understanding how you are seeing the performance. For me, the performance is actually the fuel consumption and the aerodynamic efficiency of the system. So my performance definition will actually try to prove that into picture that the current electric vehicles that we are actually functioning are are better in terms of efficiency. Yeah. Now, again, actually trying to trace this. So this is a workshop class, so don't expect me to only teach you the theoretical portions, but it is a bit experimental also. So there are things that will require your attention to the maximum extent. So try to be patient enough and um, follow me with the things that are happening in the class. So was only telling you about the PPTs, it will be very easy for me as well. But I prefer not telling that in on a continuous basis, rather explaining you the complete thing with an example problem. So that is how I believe will work for you. Yeah. Okay, so this is the model. Now I'll try to extrude the model. So pull and extrude the model. Yeah, now I'll try to give it a car look. But, yeah, so now I'll try to give it a now I'll try to yeah. So this. So I'm trying to give it a fillet. So selecting the edges particularly here. So okay, so pull and yeah, is done on this side. Now similarly on this side as well. So I'll pick this, pick this, pick this, all the edges, on this, and particularly all the points that are actually covering this part. Now the frontal portion as well, trying to make it more aerodynamic, and the back portion as well. So, so that the vortex doesn't get formed at the back. So there should be a smooth flow of air at the back also. There shouldn't be an abrupt uh, edge portion that the thing faces, which will actually cause the flow to terminate and actually it will stall. So that I don't want. So for that purpose only, yeah. So this is done. Now let me actually make it in a proper way. So, so make, make it 9. Yeah, so let me make it 90 degrees.
So your screen is not visible.
Okay, now this shows properly. So X direction is the here. So now let me create a domain around it. So let me prepare a domain there and then enclosure as I did it yesterday. So let me do it over the symmetrical plane, or else yeah, let me do over the symmetrical planes. So we bring this design, move it to the center. Okay, so moving it to the center. Now I'll actually choose a plane. I'll create a I'll actually I'll actually choose a plane and I'll pull it. So I'll actually bring it to this far and I'll actually cut it towards its center. So pull, cut up to this point. Okay. So this is now the symmetrical plane. So now let me create an enclosure. Uh, so prepare enclosure symmetric of 1000, 1500, 2000, 2500 maybe, 1000. Yeah, so now on this zero. Okay, so now this is starting from here and happens like this. So this is the symmetrical plane. Now I'll suppress this. Just be 2 minutes here. Let me. So, Amar, you can listen me, right?
Yes, but your screen is stopping and again it's resharing. So you're stopping that or automatically it's getting stopped?
Yeah, yeah. I don't know why. Let just give me 2 minutes. Let me see. No, my reset the Wi-Fi.
Okay.
Just 2 minutes.
Yeah, sure.
Yeah.
So, dear student, there is some network issue at sir side. So, sir is just restarting the system. So, please wait for the same. So, meanwhile, if any query or question, you can just post into the chat box. So, we'll take it up accordingly. So, Zoom participant, due to participants, any query, any question regarding the session, any topic. So, meanwhile, you can just post into the chat box. So, I will take it up. Thank you.
Yeah, you can please ask if you have any doubts till the time I have created this cavity or till including yesterday's class as well. If you have or face any difficulties or doubts, you can please reach out in the text and I'll try to clear it uh, as far as I can. So uh, it would be nice if you could just reach out to me for that. I'll try to clear it out. Any doubts? You can please message me. Amar, shall I proceed?
Hi, yes.
Okay. Perfect. So yeah, so this is done. So maybe the the cavity is made. Now we'll go towards the next session. So the mesh creation. So mesh will only do one kind of mesh. So yesterday we figured out, right, that medium fine mesh only one kind of mesh would work. So rather than repeating stuff again and again, we'll stick towards one kind of mesh only. So we'll take a element quality mesh that's actually suitable in size and we'll pick it up and we'll follow that itself. So okay. So uh, let me see here. By the time we can write here the element size will be taking 0.0. Element size will be taking anywhere around 0. Just a minute. We will be taking around 0.0 and the domain size will be taking 0.1, 0.5. This will be taking number of layers as 20. First layer height as 0.0000, sorry, 0.10 power minus 4. 1 10 power minus 4. So now let me first name it. So this is the symmetry plane. So I write it symmetry. Now this is the inlet.
The screen is
Now
against.
this is the outlet. Sorry, the screen is visible.
Yes.
Is the screen visible?
Yes, yes, it's visible.
It's visible, right?
Yes, the screen is visible.
Okay, okay, okay. Fine. So I have made inlet, I have made outlet, I have made. Now the walls I'll declare. So these are the walls. Uh, the walls. So now This is done completely. Uh, Now let me actually name the car inside it. So rather I'll do a and I'll name the entire body as car. Okay. So now mesh will be taking as 0.5 outer body, and this I'll be taking as 1.1 as the growth rate, 10% growth rate. Yeah, so this 10% growth rate we'll be taking here. So this is 10% here. Uh, now, now after this, after 10% growth rate, we'll be declaring the inflation layer. So now, after this, I will be naming first. So we'll be doing the sizing of the car. So name selection and here car, and this will be giving us 0.0. How much we have taken? We have taken 0.05. So 0.05. So now, after this gets updated, so now we'll give the inflation layer. So inflation layer will be giving it from here. So inflation layer will be first going to the single select. We'll select the entire body. Section name section. We'll be selecting the car portion. So car then smooth transition instead of we'll be giving first layer thickness. And in the first layer thickness, we'll be giving the first layer height as 0.0001. So 10 power 4. This will be giving us 20. And growth rate will be giving us 1.1, 1.1, 10%. Now we'll be trying to mesh it. So let me see. We can make it more finer, the mesh, because it's a bit coarser, I guess. So let's not take the risk and we'll be doing it a finer mesh. So we'll be giving it as 0.01, 0.01, 10, 10, 10 mm. Okay. So let me see how much is the number of elements in the mesh. And based on that, we can maybe do the other sizings as well. I don't think it will be much more intensive computationally. So if it is not that much intensive, let us not maybe do it. But it takes some time. So rather than showing you on a timely basis, we can make it. So I showed you the uh, finer mesh right here. So now rather than doing a finer mesh, I do a coarser mesh only with 0.5. So we'll be comparing both the aerodynamic designs on a coarser mesh. So if the comparison is equal and balanced between both the agencies, will be given a fair chance of comparison because your all the mesh parameters that you are declaring are constant enough for declaring of the mesh size. Yeah, your mesh quality won't be a problem in that case because herein you are having a complete set of geometrical structures that are available, and uh, so it is meshing right now. Let me show you. So yeah, it is meshing, but it is taking a lot of time, right? In 10 mesh size. So let us and maybe revert it to 0.0. Maybe revert it to 0.05, and in that scenario, let us mesh it again. So it is measured. Okay, so it is meshing. So it is meshed right now. So yeah. So now let me see how many elements are there. So it is around this. Okay, just paste it here. Number of elements. Okay. Now let us take this to the updation. Before that, let me show you the inflation layer that I'm talking about. So see this inflation layer. So this will capture the shear layer properly. So everywhere at the corners, at the sharp places, these are properly defined. So this will not allow an abrupt jump, and it will capture the boundary layer near the surface. So that is what I was trying to make you understand the significance of inflation layers. So that is how this is. So okay. So now let me close this up, and after closing it, now let us open the fluent part. In the fluent part, as we discussed yesterday, double. So as we discussed yesterday, double precision, and with double precision, a number of parallel solvers, you switch it on, and in the parallel solvers condition, actually you actually do complete things like you click here, number of solvers as 5, hit OK. Okay, so this is done. Now it is opening up. So let the Fluent open, and once the Fluent is open, there is no problem. And once this is done, we'll record this, and after recording this, we will switch it towards condition. So see, this is the symmetry plane. This is the symmetry plane. This is inlet. This is outlet. These are the walls. Okay, this is the car. So now we'll give a condition. So minus 9.81, minus 9.81 is the gravity. We'll give the viscous boundary as k omega SST, k omega with SST. So this is done. Now boundary layer at the inlet will give around 20 meter per second as decided. So this is 20. Then outlet is this is 20. Outlet is pressure outlet. Outlet is pressure outlet with a constant pressure. As I told you, the moving walls. The reason for the moving walls is that when the air moves from the inlet, it doesn't faces a zero terminal velocity at the wall section, so it uh, experiences a constant air throughout the complete surface. So instead of this parabolic distribution, it faces a constant distribution as it faces the atmosphere, so that it resembles an infinite boundary layer, boundary of the uh, enclosure, and there is no restriction of the flow. So now in the Hmm. So this will be computing some inlet and reports will be for the areas, right? So liquid areas along the y-axis are compute 2.92. So this will be copying and will be going to the reference values V. This is 4 meters. This is enclosure. And now what we want to report, drag, we want to report CD. So CD will do the car, okay, and CL. CL is not needed, but still, for the sake of completion, we are doing it. But CL is not needed, just to make you confirm. Okay, now let me check once. Oh, so it is steady state, not transient. So now let me do the hybrid standard initialization, solving this equation. Now solving it, that is done. Now let me lift iterations, solve. Now this is solved. Let it solve. You can see it is getting plotted now. And yeah, so I think it will converge very fast because the mesh is fine only and doesn't require much attention to convergence criteria. So I think you can see the CD plot and CL plot both are wonderfully behaving. And so you can see here uh, how the CL plot is also showing a positive lift at the moment. So the aerodynamic design is actually working fine and properly. So if time permits, we can do a post-processing also of the pressure contour to check and compare between the two, to check the uh, boundary layers and how the separation is happening. So that also we can check it. So before that, I think it will convert fastly only beforehand only, but let us see. So it has the continuity has reached to -2, -3 almost, and XYZ velocities have also reached to -4. So the criteria is -4 and -6. So I think it will reach very fastly. So that's not a point of concern at the moment. Yeah, so it is actually converging. It is on the sake of convergence, still running. So -3 is achieved, almost -4 is achieved. So now I think it will converge in the next 10 to 20 iterations. 10 iterations. That is not a problem to worry about. So let it happen. By the time it is converging, do you have any questions? You can write it in the chat. I will be really happy to answer it. Please, because it's a one-way communication, so I am not able to understand what are your questions. So can you please write it in the chat, whatever, or if you're understanding everything, please write that as well. Okay, or something. Please. Do you have any questions? Can you please reply? Amar, can you see any questions appearing? Can you please reconfirm?
No, there is no any questions. So can continue.
Okay. Okay. So let it converge. Maybe in the next 10 iterations it would converge. And then maybe we can uh, compute the results. We can post process it, and then we can take the next geometry compare for the sake of completion in comparison between the two electric vehicles. Uh, this actually gives you a framework of the autonomous and electric vehicles also, and also the ANSYS software that is much more used and accepted in the industry. So see, it is converged before only. So it is converged. You can see the solution is converged, and your things are flat. So now you can record it. You can record the CD, compute the CD. So this is the CD. So let it so it is converged. Let me post process. Let me share my screen once again. Just a minute. So, yeah, let me share the screen. So we can copy this and write it here. The CD is here. We can copy this, and this becomes this into this. So this is your CP, and that is showing your mechanical power consumption or performance. Now, let me also take, for the sake of completion, one plot of to show you how to take a plot as well. So over the symmetry plane, let me plot the velocity. So let me plot the velocity. So see, this is how your velocity completely looks like. So the bluff region is a lot at the back, but at the front, your separation is minimal. So that is the reason why it is um, separation is because of this termination at this point. It is not because of the aerodynamic surface. If the surface would have been a bad design, then separation would have started or abbreviated here, like it happened here. It could have happened here as well, but the design is fine aerodynamically. So now let us compare with the other design. So before that, let me uh, copy, let me snip it maybe. So this is the one. This is the first one. So let me snip it and tag here. So this is the first design. Now the second. So before that, let me close this up and yeah, let me close this up as well. Now, meanwhile, let me bring another fluent here and copy the other part. E-car concept. Yeah. So this one, let me open. So now we'll be comparing between two different autonomous electric vehicles, and see how the performance is actually varying between the two to compare its mechanical efficiency and aerodynamic performance, like we did it in first case. Okay, so I think, yeah, so now it is there. So let me turn it up. So the best part of coefficient comparison is that in the coefficient comparison, you don't have to worry about the forces. You can just compare the coefficients with each other, and that will give you a very fair enough idea about what is the performance of the vehicle. So rather than completely relying on the forces, you can still comment on the performance as well. That is the benefit of it. Okay. Sorry. So let me do it this way. Okay. So now this is correct. Now let me see if this is fine completely. So let me try and compare it. Completion is the key. Or else, yeah, leave it. So now create an enclosure out of it. So before enclosure creation, let me do a symmetry thing. Okay. So design for the sake of this thing, symmetricity. Let me do this also symmetry. Full. Now keep it aside to a certain distance. Move it here. Now full cut up to the cut. Oh, sorry. Full cut to oh, cut. Oh, sorry. Yeah. So yeah, now let me create it. So we share the screen. Again, I don't know why it is always disconnecting every time. But yeah, now let me do it again. So design, start. Yeah, so now before pulling, let's keep this to this part, this side, pull up, up to. I'll do one thing. Let me do this like this. Let's see. So that was not a problem. So prepare enclosure. Let me prepare an enclosure of it. So this is 500. This is 1000. This is 2000. This is 500. 500. 500. 500. Yeah, this is done. Yeah. So now press the physics. So now this cavity is being made with these sections into it. So yeah, now this is done. Now let me take it to meshing. So now meshing. Yeah. So in the next class, I'll tell you what we will be starting. So in the next class, we will be getting an introduction to autonomous vehicle and the concepts regarding it that we are covering in today's class and yesterday's class. And thereafter, we will be starting straight away with the project because it's a very short course. So not wasting your time digging too much into details of technicalities. I'll take two UAV concepts and then compare that as well. So uh, comparing the performance of fixed wing UAV, a quadcopter UAV, and uh, then a large aircraft, and that's how we'll be covering that. So maybe yeah, three classes it would sustain that as well. So it would be completed in that. So yeah. So let me see. Now I would have liked the it would have been a longer class. We could have touched upon concepts of MATLAB as well and try to make you understand how to do Simulink and MATLAB modeling of these autonomous and electric vehicles. But I think that will be too much to offer as per the timings constraint in this class coursework. So rather we can take it maybe in some other class down the line. Yeah, this will be the walls, will be outlet. This will be inlet. And this will be the motor vehicle section. So yeah, that is there. After that, these things are done in outlet walls. Now let me do similarly here. So this is 0.1, this is 0.2, this is 1.1. This is a smaller section, so let me name it as 0.000. So after this, uh, yeah, this is how it is done, and then thereafter, let me do the inflation layer assignment. So inflation layer first, we select complete thing, what then this car, Smooth transition, first layer thickness. Number of layers is 20. Sorry, first layer height is 0.0001. This is 20. This is 1.1. Okay. Now let me mesh it. So it is meshing. So let this happen. After that, once this is done, we can maybe do the analysis of this and compare the performance of both the autonomous vehicle side by side. So this is actually the um, electric vehicles analysis as well as ground autonomous vehicles. So basically, in the complete system, there are two things. So this is the ground autonomous vehicle. After this, we'll be doing the aerial autonomous vehicles. Aerial autonomous vehicle is a different thing. So that the aerial autonomous vehicle will be taken into consideration in the coming class, wherein we'll be also redefining whatever things are there and also taking into consideration these uh, autonomous vehicles side by side. So the aerial autonomous vehicle and the ground autonomous vehicle, both things we'll be doing, and then coming to a conclusion that which is feasible and how to approach the problem in a sustainable manner. Okay. So it's taking some time. Let me increase the size maybe to 0.5 and this let it be 0.05. Okay, now let us see. Not machine actually. So uh, let me do one another thing. So maybe taking this is a bit different model from the thing that we are considering. So let me take this one. Okay. So we have the 2D model. So we can create as we created in the last one. The this geometry we can create it and then create the enclosure of it and then compare both the ground autonomous vehicles side by side. So let this yeah, that is a better idea. So in that manner, we can compare both the things by creating our own geometries and then coming to a consideration as well. So let me give, yeah, this is a better one. So, right. Yeah. So let me complete it from here. Hmm. Let me finish this and take a curve so that I could complete this in a proper way. Right? Now pick this again and bring it till here. Finish it. And then again a spline. This I'm doing you to help you understand also that how to recreate if the geometry is very difficult to understand, then how to recreate it and then extrude it. So these are the tips and tricks that you need to understand for proper. Okay. Yeah. So this is done. Now pull it. So I'll delete this completely first. I'll delete this completely. I'll bring this and I'll pull this. So I'll pull this. This is a better thing, right? Because then it creates a symmetricity between the two designs that we've done. So now, so Amar, I'm audible, right? Okay. Sure, sure, sure. Am I audible now? Is it fine now? And the screen visibility is clear, right? The screen visibility is clear, right? So now this is done. Now let me take this into notice as well and then do that. So both the places are done. Now let us create a symmetric plane. So basically like this, and this. So now this is fine. Now let me bring this up to here and pull it till the central pin. Pull, cut up to the central pin. So now this is done. Now let us create the enclosure of it. So prepare enclosure this. So now let me do the dimensioning of it. So this is 1500 Yeah, so this is 1500. This is 500. This is 1000. This is 1000. This is 0 because it's a symmetric plane. This is 1500. Uh, this is 1000. This is 1000. This is 2500. Okay, so now this is done. And this is your internal model structure. So press this, and then your model is ready. So now this becomes a very nice clear-cut comparison of the two. So now this I close it and I open this. Okay, opening this. Is it visible now? I think it should be visible to you. Can you please recheck it? I think it should be visible. The screen is visible, Amar, right?
Yes, yes, it's visible.
Screen is visible, Amar, right?
Now it's not visible. I think it's loading though.
Okay, it's visible,
Yes.
right? Okay.
Yes.
Yeah. So yeah. So let me make the things again. The naming part. Delete. Yes. So this is symmetric plane. Symmetry. Mm, these are the walls. This is the outlet. Uh, this is the velocity inlet. Similarly, as we did in the last one, we are doing it here as well. Just the geometry is changed and rest everything is same only. So we are doing the same process to compare the aerodynamic coefficients properly. So this is the part. Now let me see here. Before that, here, let me see. Yeah. So now single select body, apply, and okay. So now this is so yeah, this is done. So now we'll compare this as well. So we'll see the number of elements here. It should be same only because we are dealing with the same kind of structure. So everything is same. This is same. We'll write it here. Uh, and then now we'll close this. Meshing part is done. Now the final part. That is the updation and setting up in the Fluent. So yeah, it is actually updating. It's taking some time. Yeah, so it is done. So now let me set up the model. So double precision, parallel solvers, solve this 5. Okay. So Yeah, doing the same kind of thing here as well to get a comparison feel of the cases on both the sides, and thereafter completely comparing both the things. So you can see here with the inlet, outlet, walls, symmetric lens, and car. So here you give it as the one thing I have mistakenly done. So the time when we will be assigning the velocity is we should assign it properly because thereafter, so see here, the z direction is the velocity, so that will keep improving. It's okay. So other than that, everything is same. So laminar flow, no turbulence boundary condition as k omega SST. Okay. Now we'll be doing the velocity as 20 in the negative z direction. So this is 20. Okay. And while assigning on the walls, moving walls, this has 0, this has -1, and this has 20. Okay, this is done. And now doing the reference, before reference, we'll be going here and completing along the y-axis, the car, compute. This is also of the same uh, size. So reference values in the reference value section, inlet, this you complete it, and this has 4 meters, this has enclosure, then here give it as drag, and in the drag section you give it C and report R, this has 0, this has -1, okay. Okay, done, and then Y lift as, lift will be same, this is C. Just because that is done wrongly, so that is why I'm checking the axis properly before setting up of the problem. So solving the Poisson equation, initialize, done. Now 150. So yeah, this is also set under analysis. So till the time it is happening, can you guys please help me know if you have any doubts? You can message on the chat. Please, can you do that? Please, please. You can see CL and CD are getting progressed, and CL and CD are getting progressed. So you see here, CD is also there. So let it happen. By the time, do you guys have any doubts? Can you please? Umar, can you see anything on the screen as a query or no?
There is no any query actually.
Okay.
Yeah, but the screen it's just showing
So yeah,
now
this
again
is
autonomous
happening.
vehicle started sharing screen, but nothing is visible.
Also take. Yeah, yeah. Please tell.
Yeah, now it's fine.
Okay. So it will take around 5 more minutes to converge, and then thereafter we'll post process the results. We'll do a bit of understanding of the contours, and then thereafter we'll be in a good position to do say that we have done complete understanding of the uh, analysis on ANSYS for the ground autonomous vehicles. So autonomous vehicles are working with when you see on the mechanical aspect or when you see on the electronic aspect, everything is same. But the thing that differs here is the working principle in the autonomous vehicles. The only thing that is varying factor is that it is a self-driving thing. So a self-driving thing happens in car also. Self-driving thing happens in aircraft also. So that is the autonomous mode or the autopilot mode. So it is very much common in these days. So that's what here also it is getting concerned about. So nothing, the analysis procedure remains the same, just the functionality varies a little bit. Rest everything remains similar only. So you don't think that yeah will be that will be completely different out of the loop. That's what I just showed you here that there is nothing different in this case also. Everything lies on the same principal lines. Yeah. So it is running. It will take another 5 minutes more. I'll just be on the call. Time, if you guys have any doubts, you can write in the chat. Yeah, so it is, I think it is converged only, so there's no much of a concern right now. Things are converged at this point in time. So it has become a king and it is going on a repetitive mode. So yeah, so um, thereafter this actually shows you that convergence, how much it is important, because if your results are not converged properly, you won't be. Yeah, so this is done, and this is done, and then let us compute the results. So let me give you this. So car this. So this is the CL. Sorry, this is CD. So this has lesser CD. So that is surprisingly very nice. And then you can with the so yeah, see the mechanical power loss is lesser in this design. And that you'll see in the contours also. So just give me on. So let me give it up here. R horizontal symmetry. Look, yeah. See here, the difference is so less. So let me plot velocity here. See, the velocity is disturbed flow here, but it gets disturbed in a very um unconservational manner. So it happens everywhere, but as you see, wait. Uh, as you see the disturbance of the flow in the first case, you don't see it here in the second case. Uh, so this is the second one. So let me put this also in the loop, and this gets the completion. Yeah, both the cases, if you see the negative pressure zones are more over here when it is compared. Yeah, it is more bluff here at the back, but when you see here, this is causing a much more reduced pressure flow at the back that is stopping the flow. So because of which, in this first case, the coefficient of performance or coefficient of power is higher, causing a larger mechanical loss or efficiency. And also the difference in the geometrical body. So if you make it more aerodynamically feasible, if you make more aerodynamically sleeker, it will be much more in performance. So that is how we compared the complete designs on both the cases. So yeah, so uh, yeah, we had a complete understanding of the electric vehicles in both the sense, wherein electric or autonomous vehicles in both, wherein we did a complete set of aerodynamic analysis, starting from the geometrical loop creation uh, to the the enclosure generation, to the mesh refinement, uh, to the analysis procedure. So I'll show you one more thing. So if the time permits, let us do. So this we have the results, right? So let us actually do a refined case of this same thing and see if the results are varying or not. So for this or other one. So for the other one we'll be doing so because that got converged faster. So let me take that. Uh, okay. So yeah, so let it close by that time. Till that time it will open. Hmm. Let them let it open and yeah. So so yeah. Then thereafter let me up it to 0.003. Okay. So 0.03 and this has 0.4. Okay. And see how the results are varying or not. Even if it is varying or not, it also comes to a picture. So we are making it slightly lesser to observe that is there any uh, inefficiency in the phase refinement of the mesh or not. So yeah, the mesh is done. Uh, Let us see the number of elements here. What is the difference? So it has become a little bit more. Okay. So let us compare it here. So yeah, we'll be comparing it here. So see, it's become double almost, more than double. So this is done. Now update it. Now close it. Close it. Close it. So after that, after it, let us edit and update it. See that complete thing in a different set. 5, number of parallel processes as 5, and then setting up the problem. So we won't be taking much time, another 5 minutes or so, and that will give us the result, at least the trend of the result that is varying or not. So can be seen properly. So that will also show us a quality check of the mesh that we were using for our understanding the comparison between the two autonomous vehicles, that we are using a correct mesh or not. So that also will be properly done. Yeah, so just a minute. Yeah, so minus 9.81. Mm, mm, laminar is laminar the omega plus 50. Okay, then 120 meter per second. 20. Then 20, then walls has also 20. Yeah, now reference values, inlet, projected areas, y, r, okay. Reference values, 4. Right, let me plot only CD. No, CD, r. So this is the refined mesh, right? So just to give you a, give you a honest equation. Yeah, then now this will give us a fact check also that we are doing it correctly. So yeah, this is now. Yeah, so this is running. Let it show some kind of converged result that we can interpret about. So I think yeah, it will show similar ballpark values for the drag. So it is let it happen. Around 20 iterations it will happen, then we'll get a result. Ballpark value result. Yeah, so get some sort of clarity. Let us do for 5 more iterations maybe. It is almost a straight line. Uh, can conclude it maybe. Yeah, we can conclude. So please say what is the drag? 0.14. So let us see here. Yeah, it was varying a bit. So yeah, mesh refinement is further needed. That is what we can sense from this. That so mesh refinement is a point where after further refinement of your cases, your results stop varying. So that is how you conclude it. So yeah, that is it for today's class. I hope people are understanding it properly. And yeah, so any more questions? 2 more minutes for that. If you have any questions, you can just post it on the chat. Otherwise, we can hop off. Can you please
So,
post in the chat?
yeah. So, dear student, if any query or any question, please post in the chat box. If not, I
Yeah,
believe
yeah, yeah.
that mark the attendance. If not, I'm sharing that link once again. So please mark your attendance and share your valuable feedback about the day. Yes, yes, guys, I reshared the attendance link once again. Okay, then I think we are
Okay,
good to
so
wind
we
up.
can drop off. Amar, should I leave?
Yeah,
I'm dropping
okay,
off.
sir. Okay, sir. Okay, so dear
Okay,
students,
okay, bye.
yeah. Okay, so dear students, thank you so much for joining the day 10. Okay, so bye. Have a nice day.